Hello, and welcome back to more polynomial things. Today we're looking at domain and range. Let's take a look. We want to determine the range of the following graph, and that means the lowest y value up to the highest y value. Well, it would if it was continuous. In our case, it is. But the range more specifically means everything the function can evaluate to. In our case, it can go as low as -4 and as high as +9 for the output, by the way, the output of the function. And it looks like it can be just about anything in between there, so we're actually going to say an interval from -4 to 9. Notice that we click the square brackets instead of the parentheses or a mix of the two. That's because the endpoints of an interval are going to be capped by brackets depending on whether or not they're included in the range or domain, depending on what problem you're solving. Here, these dots are filled in, meaning that those points are included in the evaluation of the function. That means that we are going to keep them and therefore use these square brackets for keeping them in. If we use the parentheses, that is like saying this isn't really a part of the function, but everything else that gets really close to it is, so we're going to say it's there, even though it's not specifically in it. But in our case, closed in circle means square brackets. Submit, good, good. Problem. Determine the domain. Perfect, this illustrates my point. For domain, we want to look at the x values that the function can take on. That'll go from -7, its leftmost point, to 10, its rightmost point. But if I tried to put in -7, 10 with square brackets, it'd tell me I was wrong. Let's actually put it in and see why we get this wrong. So it says we don't have this. Domain is x-axis, we did that right, minimum is 7. Closed circle means this bracket. Max is 10. Open circle means the parentheses. Therefore, the domain goes from a closed bracketed -7 to a parentheses 10. And we said with brackets for both ends, but if you see this open circle at the end, that means that 10 isn't really a part of that domain after all. Just everything smaller than 10 up to a point. So now we're going to look at finding the domain graphically. We want to know the domain of the function in the graph below. Is it an interval? Is it all the numbers? Is it all the numbers but one of them, or all the numbers but two of them? Well, let's see. Where can we not go? We know anywhere on this graph what the value of our function should be. Anywhere except for 3. Because right here, 3 seems to not be able to make up its mind. So we're actually just going to say everything except for one of them. And this big fancy thing says all the numbers except, and then the thing you put in this box is the exception. X can't be 3 because it can't really make up its mind on what it needs to be. In technical terms, I'm surprised I actually even show this to y'all, but that means the set, because they use the little special braces, of all things that X can be for every real number X, and this thing on the right says except 3. So you don't need to know all of that notation right now, but when you see this big fancy thing and you see that box when you click all real numbers except 1, that just means whatever you go, whatever you put in the box is the number it can't be. So alternative notation is -infinity to 3 with the u for union with 3 to infinity. Infinity always gets a parentheses because we can't really have infinity. We can just get as close as we want to it. Point is, we can't be 3. Let's go ahead and look at the finding, increasing, and decreasing domains. So we want the domain on which the function is increasing, meaning all the x values where it's going up left or right. All these problems, they sound so complicated until you actually ask, what are they asking me for? And it says, where's the function going up? And it looks like it's going up for everything that gets bigger than -4. At -4, it goes from downhill, 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 downhill to uphill. Let's just say um, x is greater than -4. Um, yeah, I'm not sure if it wants you to keep -4, but I'm going to say greater than, because at -4, it's kind of doing neither of them. Boom! X is greater than -4. It's increasing when the y values go up, when x moves from left to right, greater than -4. It's pretty straightforward, but if you have questions, I'll answer. Where is it decreasing? Where is the hill? Boom, here's the hill. It starts at x is 7, and it decreases all the way until the end of the function, which ends at 15. So we're going to do an interval from 7 to 15. But remember, we need to use a parentheses because at the top of the hill, it's not really going downhill yet. So finally, let's head on to finding positive or negative domains. This one's pretty cake. It means where is it above and below the x-axis. So we want all the places it's positive. The tough part of this is knowing when to use this thing. So we want it's positive when it's left of -4 and when it's right of 0. I mean, that part is just pretty self-explanatory. It's positive when it's above this line. And that's going to be when it's outside of this little divot. So we're going to say x is less than -4. And then we're just going to say the little cup symbol that means or. I mean, we could also say or. I think either of those things actually works. I'm not 100% sure what Delta Math is going to want, if any particular formatting, but I'm just going to use the cup just because x is greater than 0. In either of those places, you're going to have a positive function. Okay, I guess it does want the or. I am going to double check. That seems like a really weird glitch. We did the problem right, and we actually put in the solution right, unless I just made some kind of typo. Let me try that again. I'm going to just use the same formatting to see if there's a problem with this or if you should just stick to the word or. Yeah, apparently it's fine with that. There was some way that, I don't know, whenever we backspaced it and re-put it in, it gave us some kind of weird error. But we did the math right. Outside of the little place where it goes over the hill, it's under. So really, it's not too bad once you kind of get a feel for what you're doing. It's fairly intuitive even. But you are just going to have to know how to write things in interval notation. And remember that open circle, parentheses, closed circle, square bracket, and then join them together whenever you need to have two that are separate. Have a good one, y'all. I will see y'all in class.